Good morning, students. Today our topic is elastic collisions in one dimension. So consider two elastic body. The mass of first is one is m1 and second one is m2. The first body initial velocity is u1. Second body initial velocity u2. The two bodies collide each other. And assume that u1 greater than u2. Because of elastic collisions in one dimension. Yes, I want to take in one dimension. You know, well, momentum of the object in first body is P1 is equal to momentum is equal to mass into velocity. So P1 is equal to m1 u1, and second one P2 is equal to m2 u2. What is the total momentum? So total momentum is equal to P1 plus P2. So total initial momentum of two elastic body is equal to m1 u1 plus m2 u2. If consider the velocity of first body u1 greater than u2, the first bodies collide each other. Collide with second body. After that, velocity should be changed. So, the first body mass m1, second body mass m2. Now, after collision, this is before collision, this is after collision, the velocity of two bodies should be changed. This is final velocity is v1, second body final velocity is v2 after collision. The mass remains same, there is no change, the velocity will be changed. So now I want to calculate this. After collision, momentum of first body is P3 is equal to m1 v1, and same second body momentum is equal to P4 m2 v2. This is before collision, this is after collision. So you want to calculate this total momentum of final momentum. This is initial momentum, total initial momentum before collision. This is total final momentum after collision is equal to P3 plus P4. So total final momentum after collision is equal to m1 v1 plus m2 v2. m1 v1 plus m2 v2. You know well the law of conservation of momentum. Total momentum must be conserved. So the law of conservation of momentum, total initial momentum in before collision, which is equal to total final momentum. Yes, I want to use this m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. In our convenience, I want to take this, rearrange this m1 u1, this value is negative, so minus m1 v1 is equal to m2 v2 minus m2 u2. In common factor is m1 of u1 minus v1 is equal to common factor m2. So m2 of v2 minus u2. This is equation number 1. And same phenomena, total kinetic energy. I want to calculate this total kinetic energy because of the momentum is also conserved, and now here total kinetic energy of the body is also conserved. The body is elastic. So I want to calculate this kinetic energy of first body. Kinetic energy of first body. So this is first body, the mass is m1, initial velocity of first object is u1, and second body mass m2 initial velocity of object, second body is u2. I want to calculate this kinetic energy of first body of m1 u1 square. So this is kinetic energy of second body of m2 u2 square. Same phenomena before collision. I want to calculate this total kinetic energy is equal to kinetic energy in initial before collision is equal to total kinetic energy 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square. Same phenomena after collision. So I want to calculate this total kinetic energy in after collision. This is m1 velocity after collision v1, and this is mass m2 velocity v2. This is kinetic energy of m1 v1 square. This kinetic energy of second body is of m2 v2 square. So total kinetic energy, final total kinetic energy after collision is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Phenomena, I mean the law of conservation of momentum. The momentum is conserved. Same phenomena, kinetic energy is also conserved. So total kinetic energy before collision is equal to total kinetic energy after collision. Same 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Now convenient, both factors 1 by 2 is common, so 1 by 2 m1 u1 square plus m2 u2 square is equal to 1 by 2 of m1 v1 square plus m2 v2 square. Here 1 by 2 cancel. Remaining factor is m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. So m1 here u1 square, m1 u1 square, here m1 v1 square. So m1 v1 square is positive and also is negative. So m1 u1 square minus m1 v1 square is equal to, this is m2 v2 square, here m2 u2 square goes to as so negative minus m2 u2 square. In common factor is m1. So m1 of u1 square minus v1 square is equal to m2 of v2 square minus u2 square. So a square minus b square form. So u1 square minus b square is equal to a square minus b square. You know well, a square minus b square is equal to a plus b into a minus b. So m1 of, this is u1 plus v1 and u1 minus v1 is equal to m2 of, this is a square minus b square. So a square minus b square is equal to a plus b and a minus b. So this is v2 minus u2 of v2 plus u2. This is equation number 2. See, compare equation 2 and equation 1. Equation 2 and equation 1. So divide equation 2 divided by 1. We get one final equation. So divide equation 2 divided by equation 1. What is the equation 2? m1 of u1 plus v1 of u1 minus v1 is equal to m2 of v2 minus u2 into v2 plus u2. So equation 1 is m1 of u1 minus v1. So m1 of u1 minus v1, here in right side and left side, m1 of u1 minus v1, right side, m2 of v2 minus u2. So cancel the value m1 m1 and u1 minus v1 u1 minus v1, here m2 m2, v2 minus u2, so v2 minus u2, cancel. Get your final value on u1 plus v1 is equal to, here v2 plus u2, v2 plus u2, and rearrange the value. This is u1, so my plus u2 goes to other side, minus u2 is equal to v2, this is minus v1. So rearrange this, u1 minus u2 is equal to minus of v1 minus v2, v1 minus v2. In solution, your equation shows the relative speeds is equal to almost equal, but in opposite direction. The relative speeds of in before collision and after collision, the relative speed is almost equal, but in opposite direction. And next one, I want to calculate the final velocity of after collision. Final velocities of two elastic bodies, v1 and v2. And final velocities of v1 and v2. Here you know well the first equation m1 of u1 minus v1 is equal to m2 of v2 minus u2. So I want to calculate this of v1 value and v2 values. You know well v1 equal to v1 is equal to v2 plus u2 minus u1, and what is v2 is equal to v1 plus u1 minus u2. Substitute the values of in equation number 1. So what is m1 of u1? First of all, I want to calculate this v1 value or v2 value, any one. u1 minus v1 is equal to m2 of, what is v2 value? v2 is equal to, v1 is equal to v2 plus u2 minus u1. So v2 is equal to v1 minus plus u1 minus u2. So substitute the values of v2. v2 is equal to v1 plus u1 minus u2, another one minus u2. So m1 of, multiple this, m1 u1 plus minus, so minus m1 v1 is equal to m2 of v1 plus u1 minus u2 minus u2, so is equal to minus 2u2. So m1 u1 minus m1 v1 is equal to multiple of m2 v1 plus m2 u1 minus of 2m2 u2, 2m2 u2. In our convenient rearrange the equations, here m1 u1, here m2 u1. This is m1 v1, here m2 v1. So rearrange this, m1 u1, here m2 u1. So this is a positive values goes to other side, that's why negative minus m2 u1 is equal to, here m2 v1, this is negative value goes to other side, positive, so this is plus m1 v1, m1 v1 minus of 2 m2 u2. So here common factor is u1, so m1 minus m2 of u1 is equal to, here v1 is a common factor, so v1 of m1 plus m2 of minus 2 m2 u2, minus 2 m2 u2. So the negative values goes to other side, so positive, convenient. M1 minus M2 of U1 plus 2 M2 U2 is equal to V1 of M1 plus M2. M1 plus M2. I want to calculate this V1 value. So V1 is equal to, here this term is divided. So M1 minus M2 of U1 plus 2M2 U2 whole divided by M1 plus M2. This is the final velocity of first object. Final velocity of after collision, final velocity of first object, which means elastic body. V1 is equal to M1 minus M2 of U1 plus 2M2 U2 divided by M1 plus M2. So divided in two factors. So V1 is equal to M1 minus M2 of U1 divided by M1 plus M2. This is plus 2M2 U2 divided by M1 plus M2. It's a common factor for both the terms. That's why I divided in two terms. So M1 minus M2 of U1 divided by M1 plus M2 plus 2M2 U2 divided by M1 plus M2. This is the final velocity of first body. I want to calculate this final velocity of second body. So this is the equation you know well. First equation, M1 of U1 minus V1 is equal to M2 of V2 minus U2. So equation number 1. So you know where the equations of first one V1 and V2. V1 is equal to V2 plus U2 minus U1. So V2 is equal to V1 plus U1 minus U2. So substitute the values. M1 of U1 minus, what is V1 value? V1 is equal to V2 plus U2 minus U1. So this term is negative minus of V2 plus U2 minus U1 is equal to M2 of V2 minus U2. So next one, M1 of U1 minus V2, negative into positive. So negative U2, negative into negative, so positive U1 of is equal to M2 of V2 minus U2. Multiple and the M1 values, M1 U1 minus of M1 V2 minus of M1 U2 and plus M1 U1 is equal to, this is M2 V2 minus M2 U2. M2 U2. So here M1 U1. So plus M1 U1. So 2 M1 U1 plus M1 U1. So 2 M1 U1 here minus M1 V2 minus M1 U2. Here M2 V2 minus M2 U2. So here common factor, here V2, this is also V2. Negative values goes to other side is positive. This is minus M1 U2, this minus M2 U2. So this negative values goes to either side, so positive. Here minus M1 U2, here this is negative value, so positive M2 U2 is equal to M2 V2, this is negative value, goes other side, so positive plus M1 V2, M1 V2. So here in this 2 M1 U1, here U2 is common factor, so plus U2 of M2 is positive, M1 is negative, so M2 minus M1. M2 minus M1 is equal to, here V2 is common factor, so M1 plus M2 of V2. M1 plus M2 of V2. So I want to calculate the final velocity of second object after collision of elastic body V2 is equal to this term 2m1 u1 plus u2 of m2 minus m1 whole divided by m1 plus m2. This is final velocity of second order. This is equation number 3. This is equation number 4. So V1 value of first elastic body. This is the final velocity of first body. This is the final velocity of second body. V2 is equal to 2m1 u1 plus u2 of m2 minus m1 divided by m1 plus m2. In our convenience, this term is divided two part. 2m1 u1 divided by m1 plus m2 plus m2 minus m1 of u2 whole divided by m1 plus m2. The final velocity of second body V2 values. It's a very important. See, next one is a very important one. So now the final velocity of the after collision of two elastic body V1 and V2 values. I want to take in conditions first. Case 1. Case 1. Condition: if m1 is equal to m2, first body elastic body m1 and second body is also m2. If mass is same, what happens? What is the final velocity of the two elastic body? You know, well, v1 is equal to m1 minus m2 of u1 plus 2m2 u2 divided by m1 plus m2. First one is v1 is equal to m1 minus m2 of u1 plus 2m2 u2 whole divided by m1 plus m2. Here apply condition: if mass is same, two elastic body, mass is same. What happens? m1 is equal to m2. If m1 is equal to m2 means m1 minus m1 is 0. The term is overall 0. Here v1 is equal to here 2m2 u2 whole divided by here m1 plus m2. So m1 is equal to m2. So m1 plus m2 equal to 2m2. So the term is cancelled. So v1 is equal to u2. v1 is equal to u2. What happened? v2 value. Final velocity of second object. v2 is equal to novel equations 2m1 u1 plus m2 minus m1 of u2 whole divided by m1 plus m2. m1 plus m2. v2 is equal to condition m1 equal to m2. So here 2 m1 u1 plus m2 minus m2. So the term is 0 divided by m1 plus m2 is also equal to m1. So m1 plus m1. So it is equal to divided by 2m1. 2m1 m1 cancel. So v2 is equal to u1. v2 is equal to u1. If case 1, the mass of two elastic bodies is same. Two equal mass of objects in elastic objects collide each other, the velocity should be interchanged. So very important. See, v1 is equal to u2, v2 is equal to u1. So before collision, the velocity of object is u1, this is u2 before collision. After collision, m1, this is m2. After collision, velocity is v1, here velocity is v2. Before collision, after collision. What happens if mass is same? Two equal mass of object is colliding each other. So u1, u2, this is v1, v2. I want to calculate the final velocity of first object after collision. The v1 goes to u2 velocity. Second object initial velocity. v1 is equal to u2. And final velocity of second object v2 is equal to v1. Initial velocity of first object, which means that the velocity of two bodies interchange. If condition m1 is equal to m2. What happens if second condition m1 is equal to m2 collide with the rest object? What is the case 2? m1 is equal to m2. If mass is same, But the object is collided, second object is rest, which means u2 is equal to 0. u2 is equal to 0 means second object, velocity of second object is, which means the m2 object is to maintain its rest position, but equal mass. Condition velocity v1 is equal to, what is the equation? m1 minus m2 of u1 plus 2m2 u2 whole divided by m1 plus m2. This is the equation, first velocity equation. So v1 is equal to, well, m1 is equal to m2, so the term is 0. m1 minus m1, so it's 0. Here second condition, u2 is 0, which means second object is rest. So v1 is equal to, this is also 0. 0 divided by anything is 0. v1 is equal to 0. v1 is equal to 0, which means if mass is same, second target is rest position, final velocity of object should maintain in rest, so v1 is equal to 0. What happened v2? v2 is equal to equation 2m1 u1 plus m2 minus m1 of u2 divided by m1 plus m2. So v2 is equal to, condition m1 equal to m2 and u2 is equal to 0. 2m1 u1 plus m2 minus m2, so the term is 0, divided by m1 plus m2. So m1 plus m2, this is also m1, so which is equal to 2m1, 2m1, m1 cancel, so v2 is equal to u1. See, in case m1 is equal to m2, second object u2 is equal to 0, final velocity of first body is equal to 0. Final velocity of second body is equal to u1. Second body, I mean the v2 is goes to initial velocity of first object. Initial velocity of first object. So v2 is equal to, I mean after collision second body, the velocity which is goes to before collision, the initial velocity of first object is equal to u1. So v2 is equal to u1. This is two cases very important. In case 3, the v1 final velocity equation. So final velocity of second body equations. Case 3. What is case 3 condition? If m1 is a very less than of m2, which means the first mass object m1, second mass object is m2. m1 is very less than of m2, which means less object collided with a heavier object. And next one condition, u2 is equal to 0. u2 is equal to 0 means second object to maintain in rest position. So this is u1, this is u2 after collision. I want to take this conditions m1 very less than of m2. What happened? m1 very less than of m2. So m1 divided by m2 almost equal to 0, nearly equal to 0. Nearly equal to 0. Substitute equation v1 is equal to m1 minus m2 of u1. So divided by equation m2. So equation is divided by m2. So here m1 divided by m2 minus m2 divided by m2. So m2 divided by m2 is equal to 1 of u1 plus 2 m2 divided by m2. So 1 to u2. I mean the u2 is equal to 0, second object is equal to 0, the term is 0. I want to take directly, this term is overall 0, divided by m1 plus m2. So m1 divided by m2 plus m2 divided by m2. So divided by m2. So m1 divided by m2 plus m2 divided by m2, so which is equal to 1. Simply I want to take this. So v1 is equal to m1 divided by m2 almost equal to 0, when m1 very less than to m2. Condition almost equal to 0. It's nearly equal to 0. So m1 divided by m2's term is 0 minus 1 of u1 whole divided by m1 by m2 is 0 plus 1. The term is overall 0. So v1 is equal to 0 to u1, 0 minus 1 into u1, so minus u1 whole divided by 1. So v1 is equal to minus u1. See, If mass first object is elastic body collide with each other, first one is a very less than of second object, and same also second object to maintain rest position, which means the target is rest. What happened? Final velocity after collision. After collision, V1 is equal to minus U1, which means the rebounds in same velocity. This is a very, very important one. V1 is equal to U1. V1 is equal to U1. But the negative side indicates in opposite direction. So that's why the momentum, the rebounds in same velocity means the momentum is conserved. That's why. So V1 is equal to minus U1. So V1 is equal to U1. But same rebound which means collide in the reverse direction. Reverse velocity is also same but opposite direction. Negative indicate in opposite direction. When condition is M1 is a very, very less than of M2, and M2 is also 0. And next one, what happened? V2. Same condition, V2 is equal to, well, M1 by M2 is equal to 0 of U2 is equal to also 0. Substitute this, V2 is equal to 2 divided both sides of equations of M2. So here 2M1 divided by M2 of U1 plus here M2 divided by M2 minus M1 divided by M2 of U2 whole divided by M1 divided by M2 plus M2 divided by M2 is equal to 1. So V2 is equal to M1 divided by M2 almost equal to 0. So the term is also 0. Here M2 divided by M2 1 minus M1 divided by M2 is 0 of U2 divided by M1 by M2 is 0 plus 1. So V2 is equal to U2 minus the term is 0. So U2 into 1 U2 minus of 0 into U2 0 divided by 0 plus 1 is 1. So V2 is equal to U2. V2 is equal to U2. So condition number case 3. What is the condition? M1 is a very, very, very less than of M2, and condition target is also 0. Second object is 0. So second object velocity is equal to 0. What happened? V1 is equal to minus U1. V2 is equal to U2. So V2 is equal to U2. V2 is equal to, U2 is a rest condition. So U2 is equal to 0. So V2 is equal to 0. And V1 is equal to minus U1. And next one is case 4. Last one. Here M2 divided by M1 is equal to 0. Condition is M2 is very, very, very less than of M1, and second of target velocity is 0. So M2 very, very less than of M1. So first mass velocity, the first body, mass of first body is maximum. Condition M2 divided by M1 is equal to 0, which means M2 is very, very less than of M1 and U2 is equal to 0. What is the first velocity? V1 is equal to M1 divided by M1 minus M2 divided by M1. So all sides divided by M1, that's why I want to take this, of U1 plus 2M2, U2 value is 0, so 0 divided by M1 divided by M1 plus M2 divided by M1. So V1 is equal to M1 divided by M1, so 1 minus M2 divided by M1. M2 divided by M1 is equal to 0. Condition, so 0 of U1 plus the term is overall is 0 divided by M1 divided by M1 1 plus M2 divided by M1 0. So V1 is equal to 1 minus 0 is equal to 1 into U1. So V1 is equal to U1. V1 is equal to U1. And second condition, second velocity, V2 is equal to, what is this condition? M2 divided by M1 is equal to 0 and U2 is equal to 0. So here divide by both sides in M1. So 2 M1 divided by M1 U1 plus M2 divided by M1 minus M1 divided by M1 of U2. Here U2. So the term, overall term is 0. Divided by M1 plus M2. So M1 divided by M1 plus M2 divided by M1. So V2 is equal to M1 divided by M1 1. So 2U1 divided by M1 by M1 1 plus the term is 0. So V2 is equal to 2U1. conditions. Second object m2 is a very less than of first object. So target is also 0. Our second object velocity is 0. Initial velocity is 0. Our first object collide with the second object. Elastic body. Final velocity of condition. Final velocity of first body is equal to, after collision, v1 is equal to u1 and u2 is equal to u1. Thank you.